Hello, everyone. This is Alfredo Abate, your current Chicago Oracle Users Group President. Welcome to today's webinar. As an attendee, you'll be in listen-only mode. You can ask questions in the chat window, which we will monitor. All questions will be answered at the end of the presentation. We'll also be streaming live on our YouTube channel, and the recording will be available there to view shortly after the presentation is finished. It's really great to be here with everyone virtually. As you know, some of you know, the group hasn't met in person in almost a year. For those that are new to the Chicago Oracle Users Group, we welcome you. Traditionally, our group meets between 4 to 6 times a year in various locations around the Chicagoland suburbs for presentations, as well as hands-on workshops by Oracle experts, ACEs, and authors. And unfortunately, with the restrictions that are in place with COVID, we were not sure if we were going to be able to meet in person this year, so we took some cues from some of the other user groups and decided to go virtual. Today is our 4th webinar in a series of 20 that we'll be holding for the next 20 weeks. You can look at our entire schedule on our website. We've added all of the August registration links, and we'll continue to add the remaining ones, so you can register for those as well pretty soon. Our website is coug.us. Our user group runs completely unfunded. Our members don't pay any dues, and our meetings have always been free. So at this time, I'd like to take a moment to thank our sponsor, OAPS Net Partners, which have provided us with the Zoom webinar platform to use for our meetings for this 20 weeks. OAPS Net Partners are an Oracle Gold partner and system integrator with specialties in areas of financial business solutions based on Oracle applications, both on-premises and in the cloud. They also provide services in the areas of AP automation, Apex development, database upgrades, and administration. Next week, don't miss our webinar with Oracle ACE directors Jim, Rich, and Nitin on converged databases, the path to a long and healthy Oracle DBA career and eventual retirement. You can register for that on our website right now. And finally, some of you who have been part of the Chicago Oracle Users Group are aware of Rich Nemec's group, the Midwest Oracle Users Group, which he has traditionally had a one-day training day, normally downtown. The last couple of years, he's nicely invited the COUG, so we've had a combined training day. Well, this year, with everybody going virtual, they're doing the same, but they're going to have a virtual training week. So that's right, one presentation a day, the entire week of August 10th. So make sure you take a look at their schedule and register for the sessions that look interesting to you. For that week, our Wednesday presentation will actually be the same one as the Midwest Oracle User Group from Joel Kaleman on Apex new features and roadmap. So you can see those at viscosityna.com/event and register for those that you like. So today we have the pleasure of having Sean Scott with us. Sean is a principal consultant at Viscosity and Oracle ACE and has worked with Oracle technology since 1995. Sean, welcome. I'm going to try to give you control of the screen so you can show your presentation. Okay. There we go. I can see it.
Are we sharing? Awesome.
You're good to go. You're all good.
All right. Excellent. Thank you, Alfredo, and hello, Chicago and the wide world beyond. Thank you so much for being here. And thank you, Alfredo, and the Chicago Oracle User Group for inviting me here today to week 4 of your 20 in 20 webinar series. I'm coming to you today from beautiful Boise, Idaho, and I truly wish I could be there with you in person as I share today's session, getting started with Oracle on Docker. So very quickly about me, as Alfredo said, I'm a principal consultant with Viscosity North America, and we specialize in providing expertise for the Oracle database, cloud and engineered systems, as well as Apex development. And I've worked with Oracle databases for a little over 25 years now. I'm an Oracle ACE, certified cloud specialist, and board member of the Utah Oracle User Group and a member of the Real Application Cluster Special Interest Group as well. And I work mainly with rack and maximum availability architectures, the diagnostic tools, Oracle's engineered systems, and focusing on database automation, reliability engineering, infrastructure at scale, virtualization, and containers. And if you know me, you know that I also have a container problem. My colleagues will joke with me that my solution, pretty much anything database related, is to run it in Docker. But that was not always the case, because when I first started with Docker, I heard terrible, terrible things about Docker and containers. And so when I was first tasked with putting an Oracle database in Docker, I was not at all thrilled. Over time, I've come to realize that much of what I'd heard or been told about containers, in particular their suitability for running databases, was not actually true. And so I've put together a presentation for you today that is the content I wish I had access to 6 or 7 years ago when I first started using Docker. And while this is a presentation, I'll have some content. I'm going to try and demonstrate as much as possible for you. Docker is one of those things that I can tell you about, but I don't really think the wonderfulness of Docker sinks in until you see it work. So let's start off and talk about what a container is. And you may have heard people describe containers as lightweight virtual machine-like things. Containers are not virtual machines. It's understandable that we would compare them because containers and virtual guests let us do very similar things. And I see just so many analogies that compare containers and virtual guests, and those analogies always seem to minimize the capabilities of containers. Things like containers are pickup trucks, virtual machines are semi-tractor trailers, containers are apartments, virtual machines are houses. It just makes containers sound less powerful and less capable and less serious or production ready. And that's far from the truth. So I want to show you right now what containers are and how they're different from virtual machines. And to do that, I'm going to create a container on my command line. I'm going to run this on a free Oracle Cloud account using an Oracle Linux compute instance. And the first thing that I've done is I just made a quick directory called Alpine. I went and I pulled the Alpine tar file that has the Alpine file system on it. And then I decompressed that archive and then changed directory out of that. And then I'm going to run this command. This is an unshare command. And if you're not familiar with unshare, it does just that. It unshares things. So in Linux, we have these things called namespaces, and namespaces control access to things. And I'm not going to get into a whole lot of details, but what I'm doing with this command is I'm unsharing a bunch of namespaces, the mount namespace, UTS, or the user time space, inter-process communications, networking, forking, all of this. I unshare all these things so that other processes can't get to them. And then I'm going to tell my session that I want to change my root director to this Alpine directory that I've created and start a shell called ash. So let me jump out and copy this command. Oh no, I actually, beg your pardon. And Alfredo, can you see the screen, my terminal session here?
Yep, we can
Okay,
see
awesome.
it. I can see it. Yes.
Awesome. I just wanted to make sure that I was sharing the right screen, that I wasn't sharing a window and I was sharing a display. So this is that unshare command that I just told you about. And I'm going to run this and just so you can see, this is the contents of that directory that I just was talking about, that Alpine directory. So I'm going to run this command, and here I get this weird prompt. And now if I do things like say, who am I? Well, all of a sudden I'm root. But I have this session over here, which is on the same machine. And I do who am I? I see that I'm Oracle. Okay, so let's see, what's my host name? My host name, okay. Host name over here, it's the same. But now if I go here, I'm the root user, so I can change my host name to Alpine, for example. And now if I type host name, well, the host name for this session has changed. But outside this process, outside this container that I've created, the host name hasn't changed. So let me jump back into my container here and do something else. I'm going to run this command to see what's mounted or what my file systems are. And you can see that I don't have anything mounted. I have no file systems. So if I want to be able to fork processes and so forth, I need to have some other things mounted. So I'll go ahead and mount those. And now if I look at this again, now you can see that I have the temp file system mounted. I'll be able to fork processes and do all sorts of things. One last thing that I'm going to do here is I want to see what flavor of Linux I'm running. And indeed, I'm running Alpine Linux here, or at least it thinks it is. But if I go out here, whoops, that's not what I wanted. But if I go out to the host that the container is running in, you can see it's a totally different operating system. So I've been able to create this process running on a Linux host that thinks that it's running in Alpine Linux, that thinks that it has, in fact, if I look, I've only got 2 processes running on this machine. If I do, if I want to see what my PID is, it thinks that I'm PID 1. But if I go over here to the host, obviously a different process because I'm on a different machine. But look, I got a whole bunch of stuff running here on this machine. And this container can't see any of it. So I've successfully isolated a process on my machine and made it think that it was its own little isolated container. And that's what a container is. It's just an isolated process. So containers have no virtualization. There's no hypervisor associated with them. They are just processes running on a host. They're isolated and they run in this pseudo file system-like thing. Now, images are the other component in Docker. And a Docker image is just a set of directories and files. It's that file system. It's that unzipped tar file that we saw for the Alpine file system. It's based on that tar archive. And then it'll also include some JSON instructions. When we run an image in Docker, those JSON instructions just tell Docker what to do with that image and how to run the container. So that's all the containers are. They're not virtual machines, nothing like that. They don't have any boot process. They don't have any init process. And because of that, they are tremendously fast because they don't have to start an operating system. The operating system's already there. They're sharing kernel resources with my host. So there's all kinds of cool, neat stuff that you can do as far as building your own containers is concerned. Here are a couple of links that I'll provide you. This Linux containers and 500 lines of code. I think it's actually 504 lines of code last I checked. Bocker is a Docker container and 100 lines of bash. Again, a little misadvertised. I think it's 115 lines, something along those lines. And then I also have a YouTube channel. You can go on YouTube and search for Oracle Sean. I've got some videos where I have demos for Docker internals and a bunch of information on running Oracle on Docker specifically. So like I said before, containers are fast. They're sharing that host kernel and the host resources. So there's no initialization or boot cycle. They'll start really fast, orders of magnitude faster than a virtual machine. And to show you that, let's take a look. I'm going to run this script here. This is a Docker command, Docker run. And here I'm going to show you a couple of flags, this TTY and interactive. It just means I want to have an interactive experience with my Docker command, and I want it to put it onto a terminal. And then the very last thing you see there is Ubuntu. So I'm going to run an image called Ubuntu. So I hit enter, it's going to actually run this command. It says I can't find this image locally, so I'm just going to pull it down from the wide world of Docker. And we're now in an Ubuntu shell. So this is Ubuntu. It went out, it pulled these layers, these components of the image, and it dropped me into my Ubuntu shell. So you can see I've got this weird host name, which is obviously randomly generated. And if I exit out here and I do run this Docker images command, I'm doing Docker images and I want to see all my Ubuntu images. You can see that I have this Ubuntu image, Ubuntu latest. It was created 5 days ago. This Docker ps command shows me processes. ps, just like you would see normally in Linux for Linux processes. A running container is a process, and this -a says I want to see all of my containers, so it's showing me this exited container here. And we can also see that it gave my container this not very useful name, Hardcore Antonelli. I love the names that Docker comes up with. So you can see how fast it was even when it had to go out and pull that image from a resource. But let's see what happens if I rerun and try and start a new container using that same image. Okay, so I'm going to run this same command to start an Ubuntu container. And boom, it didn't have to download anything. It found my image locally. It pulled that image and created a new process with that image and dropped me right into a shell prompt. So right now, I'm in this Ubuntu container, and I can do whatever I want to do with Ubuntu. For example, let's say that I wanted to curl google.com. Oh no, I don't have a curl command. And that's because most images are intended to be really small. We don't want to have extra stuff on them. And because we do a lot of automation with containers, it's unlikely that anyone would ever log into a container and issue a curl command. So we just don't include it. Makes the images smaller. We maximize infrastructure. It also reduces the surface area. So if there's a bug or an exploit available for curl, if curl's not even there, then we don't need to worry about it. Forgot we're on Ubuntu here. I can't remember the command. apt-get install curl. I think that's it. Yeah, so let's go ahead and install curl here on this container. And you see it's just like a regular system. I can go, I can pull stuff in with apt-get. If you're running Oracle Linux, then you can do yum install. And now I run curl, and indeed I get my my curl command. So now I have curl. I can install things. I can modify and update this container and do all sorts of things. If I were to exit this container and come back into it, curl is still going to be there. You can still see I have the same image there. But now when I do this docker ps command to show me all of my Ubuntu containers, you can see that I have two Ubuntu containers now. I have this first one that is the one that I just stopped, and the first one that I created 3 minutes ago. Okay. So I said that containers are fast. How fast are they for databases? Let me do this real quick. I'm going to show you. So this is a command. Oh, that's just so ugly. Hang on. Apologies for the screen size here. So this is a command here. I'm running this docker ps command, and you can see this is a container. This is the image that it's using. And then we can see the status of all of these. And you can see that I've got a whole bunch of database containers over here. And this Oracle Database 19.3 container is not currently running. So I'm going to start that container, docker start 0193. And then I'm going to append this command docker logs f. So this is, I'm just following the logs, live streaming the logs for this Oracle 19.3 free database. And if you want to see and appreciate how fast this runs Oracle, watch. Okay, that was starting the listener. This is starting the database. And here's our database. Now it's up and running. Now I'm seeing my alert log tailed into the Docker logs. So it's remarkably fast, especially when you consider if I were going to do this on a virtual machine, that I would have to boot the virtual machine, have it start up, all of that, just so that I could get to my database. This is running on a laptop. This is just a Mac laptop. And I can take this image and I can ship this image. Well, if it were legal to do so because of Oracle licensing restrictions, I can't. But if it were legal to do so, I could ship this image to any one of you. And whether you're running a Linux machine, a Windows machine, a Mac, no matter what version, you can take this image and you can start a database on it, and you will get exactly the same thing that I'm getting right here. It is a wonderful, wonderful tool. Yeah, let me find my presentation again here. So containers are fast. Now, one of the things that we hear about Docker is things like stateless and stateful. And when I first started working with Docker, I was like, stateless, stateful, not really along the lines of what I normally work with, didn't understand totally what that meant. What it boils down to is images are stateless. I can't change an image. So if I go out and I pull that Ubuntu image that I was showing you before, and I add curl to it, for example, like I did here, I added curl to this container. Oops. So I've got curl on this one. But if I go out and I were to start a new container with Ubuntu, it's not going to have curl on it. So this Ubuntu image will always start up as the same thing. When I start the image and create a container and I add something to it, I'm diverging away from that base original state that the image was in. So I can't change the base image, but I can create a new image from a container. So let's do that. Let's look and find this container that has curl installed in it. I'm just getting the container ID because it's a little bit easier. I'm going to run this command called docker commit. And I'm going to use the container ID. I could also use this container name, Romantic Lewin. But I'm just going to call this curl Butu. This will create a brand new image for me. And now when I look and list all my images, you can see that I have this new curl Butu image in addition to my regular Ubuntu image. And now if I were to start, I'm sorry. So now if I run this curl Butu container, and try to run curl, I've got curl installed in this. So I can take these images and I can manipulate them and add things to them and install things on them. And then I can save that content in order to get an image that does precisely exactly what I want it to do. So images are stateless, but containers are stateful. I can persist data, I can persist state for my containers. I can stop and restart a container, and when I restart that container, Docker is going to pick up right where it left off, because they're storing that data in that host file system, in that virtual, or not virtual, but that file system that's created that was associated with that process. So just like I can stop and start Word, for example, on my laptop, and when I go in and I say, what are the most recent documents that I pulled up? I can pull up that list of recent documents and reopen them because it saved my state. Containers do the same thing. They save their state. Now, if I remove a container, everything that was part of that container, including its state, gets removed along with it. So if I delete a container, it's gone for good. So you might say to yourself, well, that doesn't sound really useful for databases, because I kind of want my database to like save data. Well, as long as you don't remove the container, you can stop and start it and your data is going to be fine. But let's say that you wanted to save your data outside of the database for some reason. There's a cool trick for doing that. And that is right here. So I'm going to run a container here. And instead of typing out interactive and TTY, I just abbreviate them here as -IT. And I'm going to introduce a command here, this -V option. And I'm going to tell it that I want a local directory on my machine called oradata/NFS to mount a file system inside my container called COUG 2020. I'm also going to give this container a name so that I don't get that weird two randomly selected words appended by an underscore thing. And then the last thing I'm going to do here is tell it I want to run this in the Oracle Linux 7 Slim image. The image is always going to be the last thing. Now, if I go here and I look at the contents of this Oradata directory, you can see that I don't have an NFS directory. But if I go ahead and run this, now I'm in this machine, and I can change to this directory, and oh, look, there's nothing there. But now if I go here, all of a sudden, I have this NFS files, or NFS directory. So I can change into NFS. I can look here. I can save and do things in that file system just like normal. Now when I go here, I see, oh, look, I was able to create this file on my local laptop, and it appears in the container. And now, if I were to go here and run this command to remove my container, I'm going to remove NFS. That container is gone. If I look and see, do I have a name NFS in here anywhere? I do not. But this file system that was outside the container itself, it's still there, and the data is still there. And this is a really neat trick that I'm going to show you something about in a little bit that lets you create databases literally in seconds. You don't even have to create the database. You can start a new container that you've never had before, and it will have a database there like magic, just waiting for you. All right, so what are some reasons that you might want to run Oracle on Docker? And there are a ton. For one thing, you can eliminate dependencies. My container, because it's isolated, I can have different versions of Perl or Python, different versions of a database running on it, and I don't have to worry about how they might conflict with other systems, other things that I have on my local file system. Personally, I use containers on a pretty much daily basis to test out different SQL, to run PL SQL, write scripts, things like that. It's great if you want to see how, how SQL might run differently or behave differently on different versions, things like that. It's great for hacking, experimenting, learning new things, doing any kind of performance tuning. You can import statistics from a production database into a container and make it think that it's a huge, vast 50 terabyte machine that's running on your local laptop. You can troubleshoot problems without having to worry about having infrastructure, do patches and upgrades. You see that I've got a couple of containers here. Beg your pardon, my screen wasn't running and you're missing my Ernie GIF. But you can see back here that I have these directories for AutoUp and DBUA, and this was me doing some work with AutoUpgrade and the Database Upgrade Assistant. I use this for building out labs and training environments. We just recently did a 19C class where everyone was running and working in Docker containers on 19C. So it's great for doing just a vast multitude of things with Oracle. There are some things that Docker isn't particularly good for. Running rack, you're probably better off running it in a virtual machine. It's more troublesome to do on Docker than it is in a virtual machine or on physical hardware. ASM isn't the easiest thing to do. Enterprise Manager, just because the way that Enterprise Manager is installed and it has some hard-coded reliance on host names, makes it tough to work with in Docker. TFA is the same way. Excuse me. And DataGuard is probably easier to do on a virtual machine than it is in Docker, although I have some recipes for running DataGuard as an orchestrated build within Docker, as well as sharding if you're interested in that. So with all that background out of the way, let's start running Oracle on Docker. Yeah, it's about time, right? So the first things that we need to do, go out and install the Docker desktop or Docker engine. This is free software that you download from Docker site. Excuse me. So once you have Docker downloaded, then you need some images. And one place you can go for these images is Oracle's container registry. The container registry doesn't have a whole lot. I think that there are 3 images out there. There's this Oracle 12c Enterprise Edition image. And oh yeah, there are 3 right there. 1 of 3 results for Oracle. So there isn't a whole lot available out there as pre-built images. And that is because Oracle has a set of libraries or scripts that allow you to build your own Docker images. So for building your own Docker images, what you want to do is go out and go to the Oracle database download site, find the Linux x86-64 zip file, not the RPM, zip file for whatever version of Oracle you want to build an image for. In this case, we're just working with 19.3. You'll create a directory for the repository. And then you'll go to this GitHub repository that Oracle has of Docker images. And you'll pull this image, or I'm sorry, you'll pull this repository. You can either git clone it into the directory you've created, or you can download and unzip the archive directly into that directory that you created. And then at that point, you're going to have a directory with all of the instructions, basically, for running Docker. And those will all be in this wonderful, deep directory structure here: Docker, Docker images, Oracle database, single instance, Docker files. And you'll want to copy whatever your database installation file that you downloaded from Oracle. You want to download that into a version-specific directory in this long path. You don't want to unzip it. You don't need to unzip it because Docker is going to unzip that file for you. And there are instructions for this within Oracle's Docker repository. This isn't really rocket science or anything like that. It's stuff that you can just follow along with the instructions. And so I'm trying to show you some of the interesting, cool things you can do without getting into miring down in details about procedural stuff that's really easy to look up and find. And if you do have questions, you can always absolutely feel free to contact me and I'll help you out with that. So now we've created a directory. We have the Docker file repository. We have our installation file available. We've installed Docker. We can now build an image. And Oracle provides a script for doing just that, and it automates pretty much everything for you. It just takes two parameters, the version that you want to build and the edition. So here, I'm going to build version 19.3 in Enterprise Edition. And that's all that there is to building an image. Well, that, and you need to wait a few minutes because it does take a few minutes. It's going to go out, Docker's going to go out the first time. It'll download the Oracle Linux base image. It's going to add some libraries, some files, some executables, and so forth. It'll unzip the database install file and then perform the software installation. And you'll see all of this happen in command input that goes by on your screen as the build is taking place. And again, building an image isn't really rocket science. There's not a whole lot of knowledge required to do it, especially if you're using Oracle scripts. So with that image created, we can now create a container for a database. Now remember that a container is a running image. So to create a container, we're going to issue this command, docker run. This is the most basic, most minimum command that you can run for creating an Oracle database in Docker. The only thing we're doing here is we're telling Docker that we want to run an image to create a container. We're giving it this -D option, and that means that we want to run it in detached mode. Detached mode just turns this into a background process so that the state of the container isn't related to the state of your session. So if you were to start a container live, like you saw me a little while ago at the beginning of the presentation when I was talking about how fast it is, you might have noticed that when I exited out that those containers stopped, and that's because they were related to my active running session. And then the very last thing that I'm providing here is the image that I want to use. This is the image name that Oracle's scripts are going to create, this Oracle Database 19.3.0.ee. So that's a bare minimum that you need. But that doesn't give you a very useful database container. So I'm going to show you a couple other things that we can do to make it more useful. The first one here is this --name. --name gives it a meaningful name, 0193 in this case. And then there's this -p. -p tells Docker that I want to map ports. Remember that Docker is isolating our process, but we have the ability to open up some access to and from the container. In this case, I'm telling Docker that I want to map port 11521 on my local machine to port 1521 in the container. So now I can use port 11521 and let's say open SQL Developer. And I can connect SQL Developer on my laptop or my desktop or wherever to a database running in a Docker container simply by using this port, this 11521 port. Then on the next line, you can see that I'm mapping a volume. I'm mapping a local directory or a data /0193 to this directory opt/oracle/oradata. And that's where all of our database data is going to live. We're not running a database in ASM, so this is all going to be a file system-based database. And all of our data files are going to be in this oradata directory. So now this data is going to be local on my host file system and not part of the container. So if I remove this container, my data will persist afterward. On the next line, you can see that I'm giving it this -e, and this -e is setting an environment variable. So just like I want to be able to set an environment variable in my host operating system, I can run this -e command, and it's going to set the value of Oracle SID to 0193. And that means when the database gets created in my container, it will create a database called O193. And then the very last thing you see here is the image name that I want to run, which is Oracle Database 1930-EE. So I'm going to run this command for an 11G database. This is an image that I just created a couple of days ago over the weekend. And so I'm going to map port 1121 in this case. I'm going to give it a slightly different path because this is a different database. I'm going to tell it that I want to create an Oracle SID called COUG 2020. And then at the very end, I'm just going to tail my log output. So we'll give you a chance to see what an Oracle database build looks like. This is going to create a database for me right here on the fly through automation. So you can see first thing it does is it starts my listener, and then it's going to go in and it's going to start running the database configuration assistant. And this will just take a couple of minutes. In the meantime, let's skip ahead here, and we'll start talking about a couple of tips and tricks. Now, I mentioned before that my database, that I can store these files, my database files, in this external directory, right? So if we take a look here and look in this O11, for example, I can see that it's created a subdirectory for the database that I'm running, that I've just created. And indeed, there are all of my data files. Everything that I need for this database is here locally on my machine, on my host machine, totally accessible. Oops. And in just a moment, we're going to see we're up to 45%. We're going to see that it's going to add some other stuff into this directory. But what I want to show you here, this is a pluggable database. Beg your pardon. This is a pluggable database. And so this is that subdirectory with my Oracle SID. Here are the files for my pluggable database, my control files, my seed database, redo log files, and so forth. But over here, you see there's this additional directory called dbconfig. And underneath it, it has a subdirectory that is specific to my database SID. And you see I've got my listener, my password file, even my Aura tab file, my TNS names, all of that configuration information is over here inside my Aura data directory. Now, this isn't where you would normally find it. In fact, oh, here, our database is ready to use now. So if I now go here and look, now I've got this new directory, this dbconfig. And sure enough, it's got all of these extra files in it, all of my configuration files. So the reason that this is important or interesting to us is that if all of this is outside the container, I can delete my database. And not only are my data files left behind, but all of the configuration information for my database is left behind. TNS names, my password files, wallets would be there if I had any wallets, my Aura tab file, all of that is there. And that's everything that I need to create a database. And if you look at it like all of my database gold images files are in this directory, I could copy that to a different directory, right? I could do this. Find the right window. Oops. Oh, that's not the one I wanted. I want this one here. This is the one that I wanted. Okay, there we go. So I can copy the contents of this O193 directory into a brand new directory called clone. And this will take just a second. Bear with me. There we go. So now I've got this brand new directory called clone. And clone is going to have everything that was in O193. And if you look, oh, that's just so ugly. Sorry about that. So if you look here, I don't have a container called clone. I don't have a database called clone yet. I'm going to create one right now. Now, if you remember, I was creating that 11G database. It had to go and run the database configuration assistant. That's because when Docker started, the container starts running and there's a script that says, is there a database here already? No, then I need to create one. If it sees that there's a database there already, it just skips ahead and starts it. So I've done a couple things here. I changed my port. I changed the directory. It's the same image. And I'm going to tail my logs. And watch how fast this is. There's the listener starting. Boom, it went straight to starting my database. Even though there was no clone database before, this container started. It found the configuration files in the proper location in that Oradata subdirectory that was mounted to this container, and it just started the database. So we skipped that whole process of doing the database configuration assistant, all of that. So this lets us create databases virtually on the fly, virtually instantly, in a matter of seconds. And certainly in under a minute, I can have a brand new running database, which is great because let's say that I'm working on something where I know that I'm going to have some sort of destructive process running. Maybe I'm testing out an upgrade. Maybe I'm testing out a backup or something like that. And I want to be able to restart a container from a known starting point. Well, I can do this. I can create this gold image of my data and my database and just boom, start it. Great if you have test environments, if you're doing anything with folks that have any kind of regression testing where you always want to start out from that initial known state, anything like that. The only thing you need to be aware of is you need to change the name and you need to change the port that it's listening on if you're using a port mapping, and change the directory. What you don't want to do is this. You don't want to put all of your data files in a non-specific directory, because you can see here, if I go into this directory, you know, if I, oops, it's gonna be system. So if I want to see, look, I've got all of, that didn't work, did it? Oh, that's because it's a little further down. Here, we'll do this. So I've got a whole bunch of system DBF files nested in all these subdirectories. If I were to create all of my databases in this Oradata, each new database would find a system data file there and would find all of my configuration files and so forth, and it would just be overwriting, and it's a mess. So don't do this. Definitely use unique paths for everything. You can also go in and you can customize all sorts of different things in your Oracle database creation. You can set the password that you want to use. You can set the SID, the database SID, just like I showed you with that 11G build. For databases that run with pluggables, you can set the PDB names. You can change the character set and the time zone. So that's building and creating databases in containers. A couple of quick tips here. You want to be able to remove your log files from running containers. The database containers that are created as part of Oracle's libraries and Oracle's recipes, none of them will run in, well, none of them are by default running in archive log mode. So you don't have to worry about the database generating archive logs in the background and filling up your file system. That's not a concern. But there are audit files and trace files that are generated as part of just Oracle being Oracle and doing what it does. Over time, these can fill up. And whether you're running on your local file system with that mapped directory, or you're running a container and embedding all of the data files and directories and so forth within the container itself so that nothing persists with that volume command that I showed you. Eventually, if you leave it running long enough, the voice of experience here is telling you that your machine will stop working because it fills up with all of these trace files and audit files especially. So if you're going to leave a database container running on your machine for a long time, you definitely want to go in there and do a little bit of housekeeping. Something to note, you're probably thinking to yourself, well, dude, just write a cron command to do that. Yeah, this is a thing about containers is that they don't have an init process, remember? So there's no cron running in the container natively. You can add cron, you can get cron-like features as well. You can create a container that has systemd and initd and everything built into it. It's just this kind of a pain in the neck. And it makes the container bigger and uglier and less pleasant to build and use. So considering how infrequently something like this is going to need to be done, it's not worth the trouble to go through the process of installing cron and everything. Just go in occasionally and purge these things out if you're going to be using a database container for an extended period of time. Like I said, you can connect to Docker from SQL Developer. So you're just going to put in the service name, which is your SID. It can also be your pluggable database name, and whatever port you mapped for Docker to translate port 1521 to. And here you've got the ability to connect to your Docker container from SQL Developer or from any other tool for that matter. Excuse me for just a moment. Running out of voice there. So with that said, there are a couple of things that you can do to customize Oracle's default Docker build scripts. Let's take a look here real quick at what is in one of these directories. So these are the files that ship with the Oracle Docker builds. And you'll see a couple checksum files here. These are just making sure that the zip file that you downloaded is the correct zip file. And then you see these shell scripts, check DB status and check space and create DB and install DB binaries. These are all just shell scripts that are called to perform these different things, like check the status of the database. In fact, if we go here and we run this Docker PS, we see this information here, up 7 minutes, healthy. Healthy comes from this check DB status script. So it'll tell you whether the database is healthy or not within your Docker command. It checks space to make sure there's enough space. But there are some things that you can do in database or in these scripts to modify how your environment gets set up. And one of them is right here in this setup Linux environment. You can see here, it's not a pretty script, but it's just doing this yum install, and it's doing the database pre-install and the OpenSSL. You could go in and on here add things like VI or less or strace if those are things that you want to have as part of your Docker database images. Because again, remember, we're trying to build images that are as small as possible for distribution purposes. But you, if you're working on a local system, you're probably going to be logging into a machine and doing all sorts of things that you want to have an editor for. You might want to diagnose a process with strace. And so you need to install those things. This is where you would do that in this setup Linux environment. This run, oh, I'm sorry, let's look at Docker file here as well. So in this Docker file, you can see that we're setting a bunch of environment variables. And this is a place where if you want to have some custom environment variables set on your machine natively so that when you log into the machine, it's just there, this is where you would do that. If you want to change any part of your installation, you can do that here. And you can also do that within the install db binaries.sh or the create db.sh, depending on whether you want to modify the software installation or database creation. So these are the scripts where you would go in and modify things. And then finally, the start db script is where the database actually gets started. So if you want to start something else or run something else every time a database container is started, you can add those commands right in here. And these are all just basic shell scripts. There's nothing magical or unique about them. If you're familiar with bash scripting, then you should have no difficulty going in and making any and all of those changes that you need. All right, and that does it. This is my information, and I have a whole bunch of Docker builds on my GitHub. So I have a number of alternative ways of running Docker and building databases in Docker that are outside and sort of beyond what Oracle has provided in their repositories. If you want to build later versions than 19.3, so 19.6, 19.7, 19.8, using the response or the release updates that are available. If you want to run trace file analyzer, if you want to run Oracle sharding, data guard, run RPM installations, just a whole host of weird and cool things that that I've built over time for working with Oracle on Docker. And with that, I am done. And check and see. Do we have any questions?
You've got one question in the chat, Sean.
And for some reason, I can see the Q&A, but I don't see the chat. Where am I going? Oh, there we go. Okay, let's see. Is it technically possible to develop a script? Do you see any limitation having to do it in multiple image sets? Docker, PSU. Oh, where we're applying a PSU to a database? That's the question. Yeah, so I actually just this weekend put a Docker image that does exactly that. So that is, in fact, this database. This is a database, this 11G image. So I'm doing that right here, and you can do it. It's 2 steps, but you can see right here. These are the 11.204 installation files. It unzips those files. Here it's installing the database, and then it runs root.sh, and then I'm just pushing opatch on top of the existing opatch, so it has the most recent. And then right here we're doing the opatch apply, all within the Docker file. So this creates an image that has the this is the I think it's the October 2018 patch applied to it. But yeah, you can do this for any PSU, any security update. You can do it for release updates as well. I have similar things for my 19.6 and 19.7 repositories as well. Okay, so Ken asked, how are database release updates applied to the database and containers? You can do it one of 2 ways, Ken. You can apply a release update as part of the Docker file, very similar to what you see here. In fact, we'll take a look here. Oops. Oh. So this is doing more or less the same thing. I'm just passing some information because changing everything to a variable here rather than calling out file names. But this is just doing the OPatch apply of the database release update. So you can do that within the Docker build file. Otherwise, you can take a Docker image. I could take a 19.3 image and I could pull a release update into the local file system. You can copy files in and out of containers, and you could copy that to the container and then manually apply it, and it would be just the same as you wanted to apply a release update in any other database system. So let's see, if I want to build a Docker container and get 0196 just to install Apex and a pluggable, where can I get a 19.6 image? So you would have to create your own images for Oracle databases. And that's because Oracle has such strict licensing restrictions. So when you saw me go and I ran an Ubuntu container, Ubuntu is open source. And so I can go out and put an Ubuntu image out on the web, and there's no licensing restriction. They're available for you to pull. With Oracle, you have to have the database installation built into the container, or built into the image rather. And so you can't distribute those images with the database software pre-installed. You have to build them on your own. So you could just go and, like I said, I have the 19.6 image information. So here I've got builds. These are my own personal builds, but these are all on GitHub for 19.6, 19.7, 19.8, DataGuard, GSM, and so forth, sharding, TFA, and whatnot. So yeah, there's a little bit of extra work you have to do for 19.6, but if you're having problems with that, shoot me an email, and I'll be happy to point you in the right direction to get you everything you need to get a 19.6 database image up and running. And Kumar had asked about the limitation to my questions more. Kumar, I'm not quite understanding what it was that you're asking there. Okay, so David, what's a licensing concern if I want to use 0196 test Apex? Yeah, if you're licensed for, well, I should take a step back. I'm not a licensing expert. My understanding is that if you're licensed for 19.6, then you should be okay to run a Docker image in 19.6. But that's the kind of thing that I don't want to tell you absolutely you can and can't do. I will say that I mean, you see all the versions of Docker and databases that I have here. I run all of these versions. I don't personally have a license, but I'm not using any of these for any kind of production use or anything like that. It's stuff that I do as part of my work and part of my work with clients. Ken asks, can you unplug and plug PDBs between container databases? Yes, you absolutely can. Absolutely. Yeah, they are effectively just normal, ordinary databases. There's nothing really truly unique about a database running in Docker. Of course, we're running on a file system, so you don't have the additional concerns of ASM and things like that. You certainly can. If you want to build a container that way, you can do that, but it's not typical. But yeah, the plug and unplug process, running upgrades, applying patches and so forth, you're running it all exactly the same way that you would do it in an ordinary, quote unquote, ordinary environment. Okay. All right. Are there any other questions?
It looks like it's it, Sean. We are at 1:06, so I don't want to hold up too many other folks' time, but this was an excellent presentation. I know personally I learned some stuff because I don't use Docker. So this was, refreshing to get some new ideas. And I hope others feel the same. So like I mentioned earlier, we are live streaming this on YouTube. So it'll probably be available. I think it's available now. It'll just say live for a little while as a status, and then eventually it'll just become a video on the Chicago Oracle Users Group YouTube channel. I will be getting a copy of this presentation from Sean, and we will, where you see the registration link on our website, it'll have two icons, one for the YouTube link for the video and the other for the presentation, so you can download it. And as Sean said, if you have any questions, you can get a hold of him. Thank you so much, Sean, for spending time with us today. We really appreciate it.
You're welcome. Thanks so much for having me, and thank you everybody for sticking around and joining us today.
Yeah, and we'll be back next week. For those who may have gotten on late, just check our COUG 20 and 20 for next week's presentation with Rich, Jim, and Nitin on converged databases. And we'll see everybody then. Thank you so much. Have a good day.